Good morning. So we shall have now our lesson 6 equation with homogeneous coefficient. So again, we shall be reviewing the homogeneous function, test whether the given function is homogeneous, and then give the degree. So the usual way is to submit or substitute kx, ky to the given function. It makes 2ky plus kx raised to the second power and ky raised to the second power. Solving further, that is 2ky plus k squared x squared plus k squared y squared. Then get the common monomial factor, which is k squared there. Then you can get the square root of k squared is k. Then common monomial factor again, that makes k. 2y plus the square root of x squared plus y squared. Then check whether this will be the same in a given function. If it is the same, therefore this is homogeneous. Then it is a first degree because the k is raised to the first power. So it is a first degree homogeneous equation. So we shall have now the equation with homogeneous coefficient. Taking into account the theorem that we shall be having, that will be function of both x and y, and then function of n to both x and y if they have the same degree. So therefore this is the condition for theorem 1. Theorem 2 will be as a function of single variable alone. So if these two theorems will be dealing with it, so we can have the equation of the or we can solve for the general equation then, and this will be our variable that we have to get in order to be getting the general equation. So let's have the idea. So they are asked to test whether a given function is homogeneous. So we have to find the general solution. Okay, so these are the problems. So we shall have to take the first problem. So we are asked to test whether the given is a homogeneous function. As you will see, it is x squared, y squared, and xy, meaning it is homogeneous of the second degree, because if we apply or substitute kx, ky, you will notice kx, it becomes k squared, as well as in the x squared and y squared. So therefore, the given function is homogeneous in second degree. So this will be, we shall have to look for a variable that will be changing, and we choose to be y equals to bx because this is much simpler coefficient. So therefore this value here, or these variables here or coefficient, will be substituted to the given differential equation. So y squared will be substituted by bx, so it becomes b squared x squared. Y, it becomes bx. dy, it becomes b dx x db. So this will serve as our dy. Solving further, that will be x squared plus bx squared x squared. We multiply this, it becomes b squared x squared dx, and this one multiplied by x db is bx cubed db. And again, we shall have to sum all the like terms. So you have x squared, bx squared, they have the same derivative of x. So therefore, we shall be adding b squared x squared. So that becomes x squared, b squared x squared plus b squared x equals to 2b squared x squared x and bx cubed. Then you will notice that we shall be having to get the it becomes 2x squared plus 2 squared bx cubed. So we shall have to use now our knowledge about the separation of variable. It is, you have to multiply the unwanted factors. The unwanted factors here, if we get the common monomial factors, that will be x squared 1 plus 2b squared. So therefore, the unwanted factor 6 is 1 plus 2b squared. While in the second coefficient, x cubed will be the unwanted factor. So therefore, we have to multiply it to separate the variables. So 1 over x cubed 1 plus 2b squared. So multiplying it, it becomes dx over x plus b db plus 2b squared. And then we apply now the integration. So we have to check first before applying the ln or du over u ln u plus c. We check the derivative of x. Derivative of x is 1, so therefore check. While the derivative of 1 plus 2b squared is 4b, so we need to add 4 and 1 part to balance the equation. So therefore, to get the integration of this, that will be ln x, and it is 1 part ln u. U is 1 plus 2b squared is equals to ln c, the integral of 0. So therefore, we have to multiply it before because we have a fraction here. So to get rid of the fraction, you have to multiply it by 4. So you have 4 ln x plus ln 1 plus 2b squared is equals to 4 ln c. So again, that will be plus, meaning it is multiplied. So, and 4 ln x to the 4th is means raising to the 4th power. So that will be ln x to the 4th 1 plus 2b squared, which is ln c4. 4 ln c4 using the properties of logarithm means it is the power of 4. So therefore that will be our logarithm. So we have to raise it to e. Raising to e. So our answer will be x to the 4th 1 plus 2b squared is equals to c to the 4th power. So since this is our answer, so b from the equation y equals to bx, so therefore b is y over x. So therefore we have to substitute b, so it becomes 1 plus 2y squared over x squared. So therefore you have to simplify it, so getting the LCD, that will be x squared, it becomes x squared plus 2y squared is equals to c to the 4th. And then since this is common with the variable x, so therefore we can cancel 4 by 2, so it becomes x squared plus x squared plus 2y equals to c to the 4th. So this will be our desired general equation to the given differential equation. So our next lesson, testing again problem number 2. So x, y, dy, again it is a second degree and homogeneous. So again, we shall have to substitute x equals to by dx. That will be much simpler. So last problem we have y equals to bx. So since x is equals to by, that will be the much simpler variable to be substituted to the given differential equation or homogeneous equation. So therefore we shall be using that. So therefore you have to substitute x by by, so by times y, dx is b dy y db. So b dy y db plus 2x will be substituted by b squared plus squared and 2y squared equals to dy. So therefore we substitute x by by, that becomes b squared y squared. Okay, so solving further, y multiply, that will be squared y squared dy plus this one variable here or coefficient multiplied by y db, it becomes by cubed db plus 2b squared y squared plus 4y squared dy, but is multiplying 2, so we distribute 2 with the given coefficient. So that becomes by cubed db. Okay, so we have here by squared y squared dy and also 2by squared dy here. So it becomes 3b squared y squared plus y squared dy. So therefore that becomes by cubed db plus getting the common factor of y squared. So it becomes 3b squared y for 3b squared plus 4 dy. Again, we shall be using the separation of variable. The unwanted factors here is y cubed, while here is 3b squared plus 4. So we have to multiply it by the unwanted factors. So it becomes b db over 3b squared plus 4 dy over y equals to 0. Then we shall have now to integrate. Integrating again, that will be u du over u equals to ln u. So first check the derivative of u. The derivative of u is 6b plus 0, which means we have to add 6 and we have to have a 1/6 to balance the equation, then get the integral of dy over y as well as the 0. So it becomes 1 ln 3b squared plus 4 plus ln y equals to c. So therefore, we have to multiply it by 6 because of the fraction. So it becomes ln 3b squared plus 6 ln c equals to 6 ln c. Okay, so therefore, addition will be meaning it will be multiplied, and this will be the power. So that will be ln 6, and also this ln 6. Then addition means multiplication. So that becomes ln 3b squared plus 4y6 multiplied by y equals to ln c over 6. Notice that will be 6 ln, that will be equals to ln y to the 6. So it becomes, we shall be raising it to e, and that becomes 3b squared plus 4y to the 6 equals to c to the 6. After that, we shall be substituting b to equals to x over y. So therefore, substituting b by x over y, it becomes 3x squared y squared plus 4y over 6, y to the 6 equals to c to the 6. And then you get the common or the LCD y squared. So it becomes 3x squared y 4y squared. Then we can cancel y squared by y to the 6. It becomes y to the 4. This is y to the 4. So our answer is 3x squared plus 4y squared y to the 4th equals to c to the 6. So next lesson will be exact differential equation. Thank you.